Okay, in the circuit represented below, resistance of a variable resistor there is decreased. Okay. If I decrease that resistor, the first thing I notice here is that I've got two resistors in parallel. If I decrease that resistor, my parallel resistances will get smaller. Okay, let's just take a look. Let me give an example. Let's say that that resistance there was 2 and this one was 4. If I want to work out the resistance, the parallel resistance, it would be 1 over 2 plus 1 over 4, and we see that that is 3 over 4, so R is going to be 4 over 3 ohms. Now if I decrease that, let's just have a look and see arithmetically if we can see what's going to happen. It would become 1 over 2, I'd decrease this to 3, plus 1 over 3 is equal to 1 over R parallel. So now that is 3/6 and that is 2/6, and therefore R parallel would be equal to 6 over 5. Now 6 over 5 is 1.2 ohms, 4 over 3 is 1.33 ohms. So you see that by decreasing the variable resistor, the total resistance for the parallel setup is also going to decrease. So we must bear this in mind, that the resistance in the circuit has been decreased. What will happen? Well, the voltmeter reading. What will happen to the voltmeter reading? E is going to be a constant. So in other words, the EMF doesn't change. If I reduce the current, if I reduce the resistor, I'm going to increase the current. Okay, I will increase the current. So the ammeter reading will increase. Now this is one of those occasions where if I know that it can only be one of these two, then I can immediately eliminate those two. All right, now the voltmeter reading across there is going to be, well, these are the only resistors in the circuit. So the voltmeter reading here is going to be equal to the EMF. All right, so the voltmeter reading is going to be equal to the EMF because this is the only resistance in the circuit, and therefore the voltmeter is going to remain unchanged. And it will remain unchanged because the overall resistance will have decreased, the current will have increased, and the value of V will stay the same because it is actually equal to the EMF. So there is my answer. I hope by now that you're happy and comfortable with my scribbling on the paper itself. Just remember that you've got the paper, you've got the marked memorandum, and what I'm trying to do now in the time available is not so much to go through every single detail of the question, but rather just to show you how to go about answering it and maybe picking out one or two little tricky points that the question might be hiding. So this next question, I'm going to do the same thing. I'll just answer it on the question paper itself. It's actually very straightforward. It's graphs of motion, and it really just involves some fairly straightforward calculations. Let's take a look. An electrical toy racing car is placed on the start line on a long rubber track. Aziz is holding the controls in his hand, and initially the toy is at rest. When he pushes the lever forward, the car moves forward. Pulls the lever backwards, it reverses. The further backwards or forwards Aziz moves the control, the faster the car moves. You know, the kind of thing. The following velocity time graph was obtained for the car's movements over a period of 8 seconds. All right, we see it starts. Now remember that this is positive, this is negative. We're talking about motion on a long rubber track. It's in fact going to be in a straight line. So it's moving backwards and forwards along a straight line. Now the first question says, calculate the acceleration of the car between the times 5 seconds, 2, 3, 4, 5 seconds, and 7 seconds, 5, 6, it's in here. Okay, so in other words, we want to find the acceleration between from that time to that time, and where it was going at 0, and now it is going at 8 meters per second in the opposite direction to that which it started. So in other words, your acceleration, for the first one, the acceleration from 5 to 7 is equal to delta V over delta T. The change in velocity, anytime you work out a change, you take the final velocity, don't forget the sign. So the final velocity at 7 seconds is going to be minus 8. And then we subtract the initial or the earlier velocity, which in this case is 0, very convenient. And the time taken is, if we want to be quite correct, we'd say 7 minus 5. Delta t is the final time minus the initial time, which is minus 8 over 2, and that is equal to minus 4 meters per second squared. Okay. This minus, what does it mean? Well, if the car started moving in this direction, when it got back to 0, it started moving in the opposite direction. Now, although it says minus, it still means that this thing is accelerating, but it's accelerating in the opposite direction. It's not getting slower just because the acceleration is shown with a negative. It's actually getting faster, but in the opposite direction. The second question says, when does the car move at a speed of 2.6 meters per second? Now, notice that it says speed. We know that speed is a scalar quantity. It is not a vector, and therefore direction makes no difference. So all I've got to look for here is to see wherever it was going at 2.6, either plus or minus, either in that direction or in the opposite direction. So 2.6 would be, now these are 2 meters per second per centimeter. So 2.6 is going to be 1, 2, 3 gradations up. You won't see that sort of detail on the DVD, but you'll see it when you look at your question, and it's going at that time there. And so the time is doof, 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 doof down here, and that's 1, it looks like 0.7 seconds. In fact, if I looked at this very carefully, I would probably find 0.65. You can actually get down to 5/100ths of a second. Now, it's going at that 2.6 again up here. 2.123, and that looks like exactly 4 seconds. Okay, so at 4 seconds, it's also traveling at 2.6 meters per second. But now, it goes through the 2.6 meters per second speed in the other direction. So 5.65 seconds, again in here. It's traveling at minus 2.6 meters per second. In other words, a speed of 2.6 meters per second.
Learning Channel offers an extensive educational collection ranging from grades 8 to 12 in alignment with the National Curriculum Statement. We offer DVD and workbook sets in a number of different subjects. To buy the Learning Channel series, check out our website on www.learn.co.za or call us on 011 639 0179.